A misogynistic algorithm. Prove that the Gale-Shapley algorithm always matches every man to his best valid partner and every woman to her worst valid partner. In other words, prove that it's male optimal and female pessimal. Before we get started with the proof part, let's make sure we really understand what a valid partner is. A valid partner is just someone you're matched to in any stable matching, regardless of whether it's the Gale-Shapley one or not. Let's see this in an example. So our setup has got some men, some women. The men have preference lists ranking the women from best to worst, and the women have preference lists ranking the men from best to worst. On this setup, we can run the Gale-Shapley algorithm. So I went ahead and ran the algorithm for you guys, and this is the matching that it outputs. From this matching, we can actually see some valid partners. Since there exists a matching, this one, where 1 and A are matched together, that means A is a valid partner for 1, and that 1 is a valid partner for A. Like this, we can go through all the pairings and see that B is a valid partner for 2, and 2 is a valid partner for B, C is a valid partner for 3, and 3 is a valid partner for C. For this setup of men, women, and preference lists, turns out there is exactly one other stable matching possible. So if we go ahead and copy over our setup, the only other stable matching looks like this. From this, we can do the same process and see that since 1 and C are matched up, this means C is a valid partner for 1, 1 is a valid partner for C, A is a valid partner for 2, 2 is a valid partner for A, B is a valid partner for 3, and 3 is a valid partner for B. Since this setup only has these two possible stable matchings, these are the only possible valid partners. So let's go ahead and overlay these two sets of valid partners on top of each other to see the total set of valid partners. From this, we can see that 1 has 2 valid partners, A and C. 2 has 2 valid partners, B and A, and so on and so forth. So a man's best valid partner is a valid partner, aka a woman who's highlighted since she shows up in some stable matching, and it's the best possible valid partner, so the highest highlighted woman on his list. So the best valid partner for man 1 would be woman A. And so on and so forth, we can see that the best valid partner for man 2 is B, the best valid partner for man 3 is C. Similarly, the worst valid partner for woman is a valid partner, so a man who's highlighted on her list, but is at the bottom of the list since he's the worst valid partner. So the worst valid partner for A would be 1, the worst valid partner for B is 2, and the worst valid partner for C is 3. Already from this example, we can see that we've selected all of the gold valid partners, aka the ones we got from the Gale-Shapley algorithm. So from this example, we can see the claim is true. Let's go ahead and try to actually prove it. Let's start off by proving that every man is matched to his best valid partner. We're going to do this via a proof by contradiction. So let's start off by assuming for the sake of contradiction that the matching from Gale-Shapley has some man not matched to his best valid partner. This would mean that during the run of the algorithm, some man must have gotten rejected by a valid partner. Let's consider the first time this happens during the Gale-Shapley algorithm. In other words, the first time that a man is rejected by a valid partner. What does this look like? So we're running the Gale-Shapley algorithm, and we've got some man, let's call him M1, and he's rejected by some woman. Let's call her W1. This woman is a valid partner for him, so she is highlighted on his preference list. But she still rejects him. We know by the way that the Gale-Shapley algorithm works that the only reason that she would ever reject him is if she's already partnered with someone who she prefers over man 1. So let's call this guy man 2. Woman 1's preference list must place him above man 1, and she's already matched to him. We can still learn a little bit more from this setup though, because we know that woman 1 is a valid partner for man 1. That means there's some other stable matching, not the Gale-Shapley one, where they are matched. So in this other setup, we've got the same man, we've got the same woman, we've got the same other man, we've got the same preference lists, but in this setup, man 1 and woman 1 are matched to each other. Since man 2 is no longer matched with woman 1, he must be matched with some other woman, let's call her woman 2. Now the question becomes, how do we come up with a contradiction to complete our proof? The contradiction we're going to try to reach is the fact that this is supposed to be a stable matching, but it'll actually be unstable. Remember, a pair is unstable if they both prefer each other over who they're matched with. Well, from this setup, we can already see that woman 1 prefers man 2 over the guy we matched her with. The question is, does he prefer her back? So it's possible that he does, in which case he would be ranking woman 1 over woman 2, But so far it's unclear. It might be the case that he actually does prefer woman 2 over woman 1, in which case we wouldn't have an unstable matching. So which one of these two cases is it? We know that both of these women are valid partners for man 2, since he's matched to woman 1 in the Gale-Shapley algorithm, and he's matched to woman 2 in this other stable matching. It's hard to get any more information from this in this setup, So let's copy over these preferences in this woman into the Gale-Shapley setup and see what we can learn. Well, we know in this run, we were considering the first time that a man is rejected by a valid partner, and that man was man 1. This means that man 2 could not have been rejected by a valid partner yet. Man 1 is the first one to do so. Since man 2 is already matched to woman 1 must be higher on his list. If it were the case that woman 1 came after woman 2, the only way that he would be matched with woman 1 is if woman 2 rejected him, which couldn't have happened yet since man 1 is the first to ever be rejected by a valid partner. Thus, we can eliminate this option, and we know that this must actually be his preference order. Coming back to this scenario, this reveals our unstable pairing between man 2 and woman 1. Man 2 prefers woman 1 over who we matched him with, and woman 1 prefers him over who she's matched with. They are unstable. This contradicts the fact that this is supposed to be a stable matching, and this completes our contradiction proof. Now let's tackle the second part. To prove that every woman is matched to her worst valid partner, we're once again going to use proof by contradiction. So assume for the sake of contradiction that the matching from the Gale-Shapley algorithm has some woman not matched to her worst valid partner. So we're running Gale-Shapley, and we've got some woman, W1, and she's matched to some guy, M1, but M1 is not her worst valid partner. This must mean her preference list looks something like this, where M1 is ranked higher than some other valid partner, M2. So M1 is still a valid partner since they're matched in the Gale-Shapley matching, but M2 must also be a valid partner ranked lower, so this is actually the worst valid partner. But she's not matched to M2 in this matching. Since he's still a valid partner, there's some other stable matching with the same setup with W1, her preferences, and M1 and M2, but in this stable matching, she actually is matched to M2. Since M1 is no longer matched to W1, let's go ahead and match him with some other W2 and bring W2 over here. From here, we can actually figure out the ordering of M1's preferences. We know he must rank W1 over W2. This is because he's matched to W1 in the Gale-Shapley matching, and he's matched to W2 in the other matching. And we just proved that the Gale-Shapley algorithm is male optimal. So W1 must be his best valid partner. Bringing these preferences over here, we see that we actually do have an unstable pairing here. M1 prefers W1 over who he's matched with, and W1 prefers him back over who she's matched with. So this unstable pairing contradicts the fact that we have a stable matching, completing our contradiction proof, and we're done.